purpose of this demonstration is to give a brief tutorial on logarithms. And I'm going to try to answer some following questions. What are they? How do you graph them? And what are the characteristics of those graphs? We'll do some examples of them in maybe later videos. Okay, logarithms, what are they? Well, the simple answer to these are logarithms are exponents that are unknown, or exponents when the variable is an unknown. Now, what do I mean by that? Basically, I'm saying that instead of having your unknown down here, your unknown is now in the exponent. So we're going to be using techniques to find out how to find that exponent when it's an unknown. Okay? Now graphically it might make a little bit more sense if I can show you how that looks. Remember we said that basic logarithms are unknown exponents, alright? So let's go ahead and see if we can graph some of these. Let's go ahead and graph this particular logarithm or exponential equation. And the best way to do that is with a t-chart. Remember t-charts? If I put an x in, tell me what the y result is. Okay, so if I were to say x is 0, what is 2 to the 0? And remember, anything to the 0 power is just 1. That means that my ordered pair is 0, 1. What if I put in a 1 for my exponent? What if x is 1? 2 to the first is 2. That gives me my ordered pair of 1, 2. Let's put in 2. 2 squared is 4. Ordered pair, therefore, is 2, 4. Let's just do one more, and I get 8, because 2 cubed is 8. And that gives me 3, 8. Let's go ahead and graph this real quickly. 0, 1, right there. That's like saying 2 to the 0. What if I put 2 to the first? That's like saying 1, 2. Over 1, up 2. Right there. If I said 2 squared, that's right there. That's like saying 2 to and then 4. What if I said 2 cubed? That's right there. That means it'd be 3 and then all the way up to 8 here. Now you'll notice that it's starting to curve and it's looking a little bit like a parabola. Let's do a couple of negative numbers just in case so we can see what this is going to look like. What if I have negative 1 for my exponent? That's going to be 2 to the negative 1, and that's 1/2. I'll leave it to you to figure that. And that's going to give me my ordered pair of negative 1, 1/2. Let's try a negative 2. That's going to give me 2 to the negative 2, or 1/4. Ordered pair, negative 2, 1/4. Let's graph a couple of those. If I said 2 to the negative 1, okay, so negative 1 gives me an ordered pair of negative 1 and then 1/2. Oh, right there. Negative 2 gives me 1/4. So it's like saying 2 to the negative 2 gives me a 1/4. Notice what's happening here. If I were to finally graph this logarithmic curve, I notice that it's going to get really, really steep over here, and it's going to get smaller and smaller and smaller fraction over here. And it's never going to reach 0. It's never going to reach this line here. That boundary is called an asymptote. Think of an asymptote as a boundary, okay? It's the line that the curve of your logarithmic curve will approach but never quite touch. You'll always have one asymptote, at least in your logarithm. Okay. So, I hope that answers some of these questions. What is a logarithm? Remember, the logarithm is an exponent when it's an unknown. Okay? The graph of a logarithm looks pretty much like this. It's usually a curve where one side has an asymptote, or a boundary that it approaches but never touches. The other side gets really, really steep. Characteristics? Well, we talked a little bit about those already. We said that you're going to have a boundary, you're going to have an asymptote, you're going to have a steep curve, you're always going to be crossing one of the axes here. In this case, it's going to be the x-axis at a positive 1. We'll get into how to solve some of these problems a little bit later. How do you solve for the exponent a little bit later in some other videos. Okay, good luck.